Hello learners, welcome to lesson 16, session 2. We are going to develop finding areas of combined rectangles. Now remember, yesterday we talked about combined rectangles. That means when you take two rectangles and you put them together. So we're going to do that today. We're going to look at some rectangles and we're going to put them together in order to find their total area. Okay, here we go. Read and try to solve the problem below. Mrs. Chang's vegetable garden is shown. It is shaped like a rectangle. She grows tomatoes in one part. She grows corn in the other part. What is the area of the garden? Okay, so let's think about what's going on here. What is this problem about? Who's in the problem? You're right, it is Mrs. Chang. And what is Mrs. Chang doing? She's growing a garden. What do we know about that garden? It's in the shape of a rectangle. Okay, so now that we understand what the problem about, let's go ahead and take a look at the problem a second time. Mrs. Chang's vegetable garden is shown. It is shaped like a rectangle. This is where I pause and I look and I see a big rectangle. Do you guys see that big rectangle? Now, she grows tomatoes in one part. Notice right here, we have tomatoes. Can you see the ripe tomatoes? Now, this is just one small rectangle inside a bigger rectangle. Let's keep reading. She grows corn in the other part. So notice this rectangle is corn. So she has two different areas in her garden. We've got the tomato rectangle and we've got the corn rectangle. What is the area of the garden? What is it that they want to know? They want to know the area of the entire garden. They want to know the tomato area and the corn area combined. So that's where we go back to combined rectangles. Now, I'd like for you to pause for a minute and try to see how you would solve this. Then come back and we'll talk about different ways to do it. Okay, now that you're back, how did you solve this? I was thinking I had to make a picture. So you know me and having to visualize and sketch and make diagrams and labeling. So I actually have some graph paper, some grid paper, and I took what I knew about the tomato garden and I sketched it in. Look, I even made it red. Okay, so tomato gardens, notice that the tomato garden is 5 feet long and 3 feet wide. So when I used my grid paper, I made it 5 units long and 3 units wide. Then when I added the corn section, I noticed that my length is 4. And what is my width? Well, since this width is 3 and this is a rectangle, this width is also 3. So just in case you were trying to figure out what the width of the corn is, it is the same thing as the tomatoes. Okay, so now that I have it all together, I can try to solve this using combined rectangles. What is the width of the entire garden? Because this is the entire garden. It is 3. What is the the length of the garden? 1, 2, 3, 4, 5, 6, 7, 8, 9. So my length of the entire garden is 9. Right? Length and width. So that is one way you could have solved this. So let's go ahead and take a look at some of our solutions. So if I wanted to do the combined rectangle, we could do, bring our picture back. So for this one, I would find out that the area is the length times the width, and the length is 9, and the width was 3. So my area is 27, and wasn't it feet? Let's go back and check. Yep, it was feet. So it is 27 square feet. I am abbreviating because I'm used to that in middle school. Okay, so 27 square feet. How many of you solved it this way? Let's see if you might have done something different. So another way you could do this is to look at each of the rectangles separately. So I know that my tomatoes, my area length times width, is 5 times, what's my width? 3. Oh, sorry, you can't see. There you go. So my area is 15 plus, remember, this is that additive piece we talked about. Additive means we can add them together. So after I have my tomatoes, I need to know my corn. So for the corn, remember, area equals length times width. What is the length of the corn? It's 4. What is the width of the corn? It's 3. And I get 12. Now, in order to find the total area, 15 plus 12 equals 27 square feet. Is that the same answer we found when we used the combined rectangle? So this is the combined rectangle. This is the additive method. So which one did you use? I actually wrote it out in 3 different ways. So you had to think about which method do you like. Now, seeing them all together might be kind of crazy. So I'm going to show you them one by one. If we did the additive like we did right here, notice I found the tomatoes and I found the corn, then I put them together. I found the tomatoes and I found the corn, and then I put them together. This is looking at 2 rectangles, and this is additive because we're adding them together. Did you do this one? What's another one we could have done? We could have done what we call distributive property. Do you remember distributive property from multiplication? This is our array. So this is kind of what we did here. We knew that our tomatoes was 5 and our corn was 4. So I can take my width and times it by my length, right? So my width is 3. And if we need to go back and look at the picture, my width is 3. And my length is 5 plus 4, because 5 plus 4 is 9. So this is when we use distributive property. So I want you to notice that this is actually going to be the same thing as this. We just write it in different ways. Now, it's possible that you did the array with the additive already done. So that's what we did with the corn up here. Notice that this equation looks like this equation. I did 3 times 9, and remember 9 times 3 is the same thing. So what method do you like? Do you like finding the 2 small rectangles and putting them together? Do you like adding the length and then multiplying it by the width to find our area? That's using distributive property. Or do you just like to add everything together to begin with, then use our area equals length times width? Which method do you like? So let's look at what they talk about on the back. I know this is a lot to take in, and if you need to, stop the video and rewind and watch it a second time. But remember, we are going to go through several problems, and by the end, we'll make sure you got it. Okay, here we go. On page 342, it is still the same word problem. It is still the same diagram. They're going to show us that you can picture it. That you can find the area of a large rectangle by splitting it into 2 smaller rectangles, which is kind of what we did here. We found the tomatoes and we found the corn. If we put it on grid paper, you can use square units to find the area of each small rectangle. Then add the 2 areas to find the area of the large rectangle. So they kind of did what we did on the grid paper. I drew my tomatoes and I drew my corn, and I could actually just count the squares, which is what they did here. They counted all the tomato squares, and there were 15 of them. They counted all the corn squares, and there were 12 of them. Then they took the tomatoes and the corn and added them together. And now they've got 27. So that is one method that you can use. You can also use this method, and we did do this on the other side. You can find the area of a rectangle by multiplying the length and the width. Except what they figured out is these go together. The length of the rectangle is 5 feet plus 4 feet, right? 5 feet plus 4 feet, which is 9 feet. It is the same thing. 5 feet plus 4 feet is the same thing as 9 feet. The width of the rectangle is 3 feet. So they did our length times our width to find the area, which was 27. So a couple of ways to do this. Let's see what they do on page 343. Okay, connect it. Now you will use the problem from the previous page to help you understand how to add areas. So this one, they want us to do what? They want us to add the areas. Look at model it. The equation 9 times 3 equals question mark is used to find the area. Explain what each factor stands for in the equation. What does the 9 represent? Let's think about that. What does the 9 represent? Well, it meant two different things that were combined. What was combined? Where did they find the 9? They added the 5 feet plus the 4 feet, right? They added the length of the tomatoes and the length of the corn. So in here, the 9 is the length of the tomatoes. I'm going to run out of space here. And then let's do one arrow there. And it is also, notice I'm adding because I said also, length of the tomatoes plus the length of the corn. So if we have to explain what each factor stands for, we've just explained where we got the 9. We got the 9 from adding the length of the tomatoes plus the length of the corn. Now, multiplying, remember, this is our length. I'm kind of out of space here. This is our length, right? Length is 9. Then we multiply for our width, or using our width. What was the width? It is the width of the corn and the tomatoes. They both have the same width. This is 3, this is 3, and this is 3. So our 3 is the width of the corn. I wish I had more space here. Okay. And then equals. And then what that question mark is the area. So the question mark tells us what the total area is. Okay, let's go on to number 2. The picture of the garden in Model It shows the length broken into 2 lesser numbers. Now, when they say lesser, they mean smaller. Let's read that again. The picture of the garden in Model It shows the length broken into 2 lesser numbers. What are these 2 numbers? Let's go back to the Model It. We have our length broken into 2 lesser numbers or 2 smaller numbers. They are less than 9, right? 5 is less than 9 and 4 is less than 9. So these are lesser numbers. I know that sounds strange, but listen to that again. These are lesser numbers. They are smaller. Okay, so what were the 2 numbers? They were 5 and 4. You can use these numbers to find the areas of the 2 parts of the garden. So you can take that 5, the length of the tomatoes, multiply it by the width, and get the area. Remember, this is length times width equals area. Then you can take the 4 times 3, remember this is the corn, and we find 12. So remember, length times width equals the area. So we found the area of the tomatoes. I'm going to put a big T here because that's the tomatoes. And then here's the corn, C for corn. We found the area of the tomatoes and we found the area of the corn. You can add the areas of the 2 parts to find the area of the whole garden. Okay, so that's what we've been doing. That was a lot of words though. You can add the areas of the 2 parts, 15 and 12, to find the area of the whole garden. So now we're going to take 15, the tomatoes, we'll put a T there, tomatoes, plus the corn, which is 12, equals 27. So the area of the garden is 27 square feet. Okay, so what I would like for you to do right now is number 5. Explain how you can find the area of a rectangle by adding the areas of the 2 smaller rectangles it is made from. So what they want you to do in number 5 is explain how we just did this. What did we do? Okay, first thing what we did is we found the area of the tomatoes. What did we do next? We found the area of the tomatoes. Let's look back at our work. Tell me in a sentence, what did we do here? We found the area of the corn. Okay, so our first step was tomatoes. Our second step was area of the corn. Then what did we do? You're right, we added them together. You add the 2 areas together to find the total, I'm running out of space, there we go, area. See, when I'm in the classroom and I'm writing and I kind of go off the screen, I usually have my learners raising their hand saying, Miss Russo, we can't see, and then I push it up. So I've got to try to remember to do that on my own. Okay, so this is your steps. And you know what? When you get into 4th grade and 5th grade and 6th grade, you have to explain how you do things in sentences. So this is exactly what we did. We took a sentence and explained this. We did a sentence for this, and we did a sentence for this. So now we have a 3-sentence explanation of how we solved the problem. And if someone wanted to solve it, they could come back and read it, and they would be able to do it the same way. Okay, now here's your reflect. Look back at your try it strategies by classmates and picture it and model it. Which models or strategies do you like best for finding the area of combined rectangles? So, what did you like better? Did you like finding the tomato area and the corn area and adding them together, which is kind of what we did here with this equation? Or did you like putting it all together into a combined rectangle and then you found the area of the large rectangle? Which method? Take a few minutes and write about it. Pause the video and then come back. Okay, so you had 2 things you could have told me. You could have either find the 2 smaller areas and add. So I have a small area and a small area, and I add them together. Or you could have said you like to combine the length. It's like squishing them together and multiply by the width. So we put our 2 lengths together. See right here. We took this length, 1, 2, 3, 1, 2, 3, and we took this length of 1, and we mushed them together. And then we found our area. You get a choice. How do you want to solve your area problems? Okay, let's look at 344. Apply it. Use what you just learned to solve these problems. What is the area of the figure to the right? How would you solve this? Go ahead and pause for a minute, solve it on your own, and then come back. Okay, so you could have done one of 2 things. You could have done the additive, in which we are going to add the 2 pieces together. So notice that area is going to be length times width plus the length times the width. Additive is when we look at the 2 rectangles, right? So a 4 times 4, length times width, plus my length of 2. And then what is this width again? Do you guys remember? It is 4, because if this is 4 and it's a rectangle, then this is 4 and that is 4. So now we know that this small rectangle is 4 times 4. And this smaller rectangle, the smallest one, is a 2 times 4. I use parentheses to kind of keep my numbers together, because this set of parentheses is this rectangle. this set of parentheses is this rectangle. So it helps me organize my work. Now, you mathematicians, tell me, what is 4 times 4? It is 16. And what is 2 times 4? It is 8. What is 16 plus 8? Well, I know 16 plus 4 is 20, and another 4 is 24. How many of you use the additive method? Now, it's possible you did the combined method. If you did the combined method, you put the numbers together here. Because you have to put the two numbers together at some point. Do you put the two areas together, or do you put the two lengths together? You just have to decide when you add the two things together. So in my combined, area equals length times width. 4 times 2 is what? 4 times 2. Oh, sorry, I made a mistake there. I'm getting ahead of myself. What is my length first? My length is 4 plus 2, right? Now remember, my parentheses help me keep my thinking organized. My 4 and my 2 need to be added together first before I can multiply by my width of 4. 4 plus 2 is 6. 6 times 4 is 24. Look at that. I found the answer 2 different ways. Okay, we didn't write the answer in. Let's write it in. The solution is 24. 24 what? 24 popsicles? No, 24 square. And why is it a square? It's a square because we multiplied 2 sides. Square feet. There we go. Okay, number 8. How many 1 meter square tiles will it take to cover the figure below? Show your work. So how many 1 meter square tiles? Now, sometimes if we're asking ourselves how many 1 meter squares, you can go ahead and sketch this in. So I'm thinking right now, if this is 2 right here, that means I could kind of sketch in this line if I wanted to. And if this is 3, then I can make 3 rows, right? Now, if this is 6, that means I have to make 6 columns. So I'm going to make 6 columns. Put 1 there. And then if they're not exactly even, that's okay. Remember, you're doing what you think is the best, and you know what you're doing. There we go. So if I wanted 1 meter square tiles, I've kind of sketched them in. This is going to help me figure out if I have the right answer at the end. You always want to figure out, is your answer reasonable? Does it make sense? Okay, so let's go ahead and, if we're doing additive, I'm going to show you both methods. I know it takes a little bit longer. If we're doing the additive, remember we had a 6 by 2, because remember that's 6. We have 6 times 2 is 12. Oops, I'm going to write it down below so we can write it. Okay, 6 times 2 becomes 12. Then here we have 6 times 3, right? So this is rectangle, the big rectangle. This is the small rectangle. 6 times 3 is 18. Now, what is 12 plus 18? Well, 2 and 8 make a 10, and then another 10, and a third 10. So we have 3 10s, which is 30. So if you did them individually, you can do that. Now, if you wanted to do them combined, you could remember area equals length times width. I didn't do that here, but length times width, length times width. What is the length of our entire combined? Well, we've got a length of 6. And what is our width? Remember, we have to add our widths together. 2 meters plus 3 meters is 5 meters. So 6 times 5 is 30. Now, does that make sense? If this one's 30 and this one's 30, if I were to count all those little squares, would I have 30 of them? I would, because look, there's 5, 10, 15, 20, 25, 30. So that's how you check and make sure that you have a reasonable answer. Now, I have 30 monkeys. No, not monkeys. We have square. And remember, it's square, 2 dimensions. And M. M means meters. Okay, and our last one. What is the area of this figure? Now, remember, I am going to go 6 plus 2 to get a combined length of 8 feet. So very quickly, area equals length times width. Length is 8. Width is 4. 8 times 4 is 32. Now, you could have solved it a couple of different ways, but this method seemed to work for me this time. So I've just got to find the 32. There it is. The answer is D. Okay, now what you're going to do is start working on the practice on your own. Go to the green page, practice finding areas of combined rectangles. Do your very best on it, and then watch video number 2 when you are ready to look at solutions. I know you've got this.